morning, everybody. We'll be kicking off this interview with a panel of speakers, and today we'll be discussing the evolution of the Streamr protocol, how it works, and what role it plays in a decentralized data ecosystem. We'll also be touching on the new tokenomics design of the data token and the complex system modeling carried out by Streamr's partner firm, BlockScience. So we've got a panel of speakers today, starting with Henri, Streamr's co-founder, Dr. Marek Laskowski, a BlockScience senior scientist and the lead modeler on the Streamr model, and Dr. Michael Zargham, BlockScience founder. And I'm Jeff Emmett, your moderator today, and we'll jump right into a bunch of questions here. So Henri, maybe you can kick it off explaining a little bit about what the Streamr protocol is and why we need it.
Yeah, sure. So Streamr is a decentralized protocol for real-time data. And it basically allows millions of applications and devices to share data with each other in a scalable and secure way and in real time. So how this traditionally is done is with a centralized message broker, meaning a server that everyone connects to that relays messages from data publishers to data subscribers. And in the middle, there's a broker. That could be a server running in a data center, or it could be a cloud service, but the principle is the same. Everybody connects to that. And this approach, quite obviously, isn't scalable or secure. And it leads to these data silos that don't really interconnect, right? And now with the ever-increasing numbers of connected devices and amounts of valuable data being produced, these centralized approaches aren't really good enough anymore. And they are, in fact, preventing us from creating these interconnected global data economies that would add value to all participants. So that's why Streamr uses a decentralized peer-to-peer approach, where there is no central party, but rather everyone is sort of like a data broker that contributes to the flow of data from publishers to subscribers. Yeah, but I guess we'll go into a bit more detail about those things later on. So I'll just stop there.
Yeah, totally. Very interesting. So in tomorrow's world of big data in terms of data streams from autonomous cars, from all sorts of internet IoT devices, this is kind of a new data sharing protocol between all these different sources and subscribers.
Exactly, like an infrastructure layer that helps these different participants communicate data to each other. And then you can build layers on top, like for monetization and that kind of things. But yeah, we can get further into that.
Yeah, great. I was wondering, at a high level, can you just give us a brief kind of how it works, how these different layers fit together into the Streamr protocol?
Yeah. There's no short answer to that question, but I'll try to give you the nutshell. So like I said, there's a couple of different layers. So there's the network, which I showed. It's the data transport layer. And then we can have like monetization layers on top. And now the layer that's relevant to the work that we're doing with the BlockScience guys here is exactly the transport layer, the Streamr Network. And that's the sort of lowest layer of the Streamr ecosystem. And now, so devices or applications, they either produce data or they subscribe to data. And in the Streamr Network, they do this by interacting with the nodes in the network, which are called broker nodes. So for example, an application may want to publish a data point into a stream in order to deliver it to all subscribers interested in that stream. So it sends the data to a broker node, and the broker node propagates the message to other nodes. And those other nodes, in turn, they propagate it to other nodes, and so on, until all the interested nodes and the associated applications that connect to those nodes have received the message. So it's a form of like peer-to-peer broadcasting of data, sort of. And these broker nodes form a peer-to-peer network. And the messages travel via this network to connect these applications without the use of any server or any central party in the middle. So the nodes do work, right? They use their bandwidth to propagate messages within the network and relay them to and from the connected applications. And for this work that they perform, the nodes should earn rewards, which brings us to the subject of the token mechanics and the token economics and the incentives within that layer of the network.
Right, awesome. And that's a lot of the work that you've been doing lately is basically building the tokenomics model surrounding the data token. So can you talk a little bit about how the data token fits into the Streamr model? And obviously, if Marek wants to weigh in there, then we can definitely hear from the BlockScience side as well about the design that's gone into the data token.
Yeah, so the data token has many roles in these different layers or components of the Streamr ecosystem. It's a reward token, it's a staking token, it's a payment token, and it's also a governance token. So if we sort of start from the bottom, so in the network layer, like I said, it can be used to incentivize the data transport, meaning that the people who run these nodes, they can sort of mine tokens by contributing the bandwidth to streams. And in this incentive scheme, the goal is also that people can stake tokens on individual nodes to earn a share of that node's income, and by so doing also sort of increase the reputation and maybe workload of that node. And the exact details of this are still sort of under research. But anyway, that allows you as a token holder to also sort of participate usefully in the network without actually running a node yourself, but rather staking your tokens and earning a yield on your tokens by doing so. Yeah, okay, so further up the stack, then on the data monetization layer, the token is used to pay for access to data content, as opposed to paying for data transport on the network layer, so paying for data content, right? And finally, the token is a governance token that can be used to vote on proposals about the Streamr project. So far, it's been pretty much the core team making decisions, but increasingly will be, handing over the governance of the project to the token holders, and there will actually be a sort of pilot about that happening very soon.
A succinct way to think about tokens is that they are actually representations of rights. And so what ends up happening here is that the token is a tool or a vehicle for managing the rights across the multiple layers of the system. Since it's one sort of coherent sort of ecosystem, we don't have a sort of large number of different tokens, but we need some tokenization as a tool for encoding and creating and transporting the rights that are generated through providing services, or the way that those rights are transferred or reallocated as a function of the decisions of participants, either at the broker level or at the subscriber and publisher level, etc. But although it can sometimes be challenging to keep track of many potential use cases for tokens, it's important to remember that they're fundamental use case is rights management, and their purpose is to enable coordination and align resource allocations across a multi-layer project.
Right, and so this is a reason for a specific token within the Streamr ecosystem. Aligning incentives with something like Ethereum or another network token. You may have conflicting incentives in the network. Is that correct?
Exactly, and the data token it separates the stakeholders of the data ecosystem from another ecosystem like Ether. Like in 2017, 2018, during the ICO boom, the popular question, like, why do you need your own token, right? Why not just use ETH? But ETH doesn't represent a stake in the ecosystem that we're building, and we can't really use that to sort of integrate through these layers, like Z was saying.
Yeah,
awesome.
And for people who sort of want to think about it in the context of the Ethereum ecosystem, keep in mind that anyone who's building is essentially like their ecosystems might be a neighborhood or a subsystem in the broader Ethereum ecosystem, which means, yeah, you may have some alignment or misalignment with the broader Ethereum ecosystem, but there's a sort of balance of localization. And in this case, we can imagine people who are already members of the broader Ethereum ecosystem choosing to participate in the Streamr ecosystem as a sort of move into a local neighborhood and to contribute locally rather than focusing on the sort of the larger jurisdiction, as it were. And both things matter, right? We care about both our local, regional, national, global ecosystems that we live in, and we want to make sure that we don't collapse them and think of them as all being the same.
Right, and I think actually that many tokens will become multi-chain in the future, especially as these interchain protocols evolve. So if you don't have like a product-specific token or ecosystem-specific token for something like Streamr, then you can't really go multi-chain because you'd be tied to something else, like some currency somewhere that doesn't allow you to really do this.
All right, very interesting. So tokens serve as a great decentralized coordination mechanism. And the reason for tokens for specific protocols is because you want to align people around specific actions within the Streamr ecosystem. That's great. Cool. So Marek, I know you've been doing a lot of work modeling the Streamr ecosystem. As we've talked about, there are multiple layers, there are lots of considerations. It's a highly complex system. And obviously requires some tools to design and manage that complexity. Can you chat a little bit about the digital twin ecosystem that you've been working on in CAD and how that can inform the rollout of the Streamr tokenomics?
Sure, absolutely. So yeah, right now we've been working on this model. We've invested in building this digital twin for the last couple months, and we're in the early stages of using it to evaluate various mechanisms for securing the operations of this enabling economy on the inside that we was alluded to earlier, where it's really the incentivizing the broker nodes in order to both secure the resiliency and ultimately the growth of the network by leveraging the data token. So one of the key features is that we have implemented message passing within the network. So we actually model the Streamr network down to sending individual stream messages between brokers, and I can actually show I would say an early conceptualization of that, is we've got here we've got a network of brokers, and over time we see that as brokers join this overlay, this stream overlay topology of brokers that are participating in the stream. I'm sort of showing successive slides here advancing in time. And we see as time advances, both more brokers join the stream, and the messages, we can actually look at them propagate, through the network. And so potentially we're building up to some really exciting, both insightful visualizations and insights coming out of the model.
Maybe
awesome.
to give the viewers a bit of like perspective, like a rear mirror perspective, like how did we end up here? We started the collaboration with you guys already, was it spring of this year? Started like documenting the actors in the Streamr ecosystem and what kind of KPIs and goals each actor has in there. And it was really useful already also for us in the Streamr team to start understanding, like, really you guys were forcing us to think through these things in a really relevant way. And once you guys started sort of creating the mathematical framework for that, then everything really started to sort of click together. And now seeing these early simulations and the tooling that has been created, it's really exciting to have this ability. And it's not only a tool for generating results or answering questions, it's also a tool that forces you to think about things in a really deep way. And I found that to be super useful in the process.
Yeah, in the process of creating this model, we're required to really take business level descriptions and requirements and encode them in a way that's mathematically precise. And my previous life, I worked in epidemiology, creating epidemiological models, and a lot of the realizations come from really confronting assumptions about the system. So I completely agree. Yeah.
Cool. So this system could be considered a digital twin of the Streamr ecosystem. So kind of like a digital replica, and these systems can run side by side, and you can use this digital twin to run the Streamr ecosystem through simulations. For example, if there's some kind of attack vector you wanted to design against, you could run it through a specific simulation, see how certain agent behaviors roll out, and then design protections against that. Is that correct?
Yeah, absolutely. So we find that in an iterative design process, digital twins are really key for testing ideas and new designs before putting them into production. And they really complement test networks and these sort of things with respect to understanding network behavior. Absolutely.
Could you talk a little bit maybe about like the couple of sort of focus points that we have at the moment in the pipeline? Like, what are the first simulations that we're gonna run, like focusing on the bootstrapping and the sort of how did you call it, shock tolerance or something like that?
Yeah, absolutely. So early on, we're at the stage with this model where we're understanding sort of what the shape of possible network behavior sort of takes, right, across a variety of parameter variations. And once we do that, we're going to get a really good understanding of how the Streamr network behaves in certain network phases. And once we get an understanding of that, we can start doing some really exciting stuff, as you alluded to, Henri. We can look at by parameterizing the network in certain ways, look at what would happen if let's say some shocks were introduced into the network. So for example, an internet cable, an underwater cable is severed or something like this, and see how the network responds to to shocks like that under different assumptions, many different assumptions.
Yeah, I'd like to also add that there's some really interesting dynamics that emerge from the combination of sort of protocols and rules and sort of behavior of nodes. And this comes from the fact that nodes aren't actually totally under, or the broker nodes are not totally under our control. They're contributors who contribute according to the rules, but they can contribute for a range of reasons. And what the sort of existing literature tells us is that for peer-to-peer networks, there are sort of pre-financialized networks that do work, and they come predominantly from a sort of reciprocity model where the brokers participate because the other brokers participate. And when you introduce financialization or rewards associated with participating in such a network, you actually have the risk of degrading or removing the underlying reciprocity based contributions. And so one of the challenges in this modeling is to sufficiently parameterize the model that we can explore different degrees of sort of financially motivated nodes and more sort of first principle motivated nodes, or nodes with what we'd call like their own intrinsic utility. That might be because you're actually producing or consuming as well, that you're serving as a broker, not just because you're going to make some rewards on a per period basis for your contributions, but because you actually want to distribute or consume something, and that you just have extra capacity that you service others with, so they will in turn service you. And as challenging as it might be to get our heads around it, it's not as simple as thinking of this like a financial market. We have to treat it like a sort of mixed process. And when we do shock analysis and we evaluate various constellations of parameters, we're really asking questions like, well, what if most of the nodes are only sensitive to what they're making on OpEx costs versus revenue perspective, and a small number are fundamentally contributing? Or what if there's a different mix? Or maybe there's just a tolerance level. Maybe you don't need as much margin to consider it worthwhile because you view this as valuable, but you're still going to stop as soon as it seems to be unprofitable. And there's actually quite a lot of circumstances, and it's not even likely that everyone in the network will occupy the same sort of persona. So part of the reason the models are so important is they help us ask which constellations or scenarios actually result in healthy dynamics for the streamer economy, and which ones maybe don't, so that the designs can be iterated upon or the live system can be managed and moved in a direction of a healthy economy. And I can't really emphasize that enough, because one of the biggest challenges with model is ultimately you're making lots of subjective choices, and the only way to do that rigorously is to basically make all the choices and look at which ones work and which ones don't, so you get a sort of landscape of what's healthy and sustainable and what's not.
So, we talked a lot about, how this digital twin can be used during design time, in the sense of designing the network, designing the economics behind it. But not only that, but also during, once the network's out there in production, digital twins are very useful for maintaining, those networks in this, in the sense that, what we can actually do that's very exciting is we can take real world data and parameterize, these models with essentially live data to understand, what's going on in the network in a very rich and real-time manner.
And actually, we could. Oh, I was gonna say, Jeff, I think even though you're moderating it, it's a good place for you to comment, because you've been doing some research on sort of commons and governance in commons systems. So I don't know. I think you should take the floor as speaker, not moderator, for a moment.
Yeah. Well, I was just also going to point out the precedent that this, digital twins of complex systems has in the real world. In cyber physical systems like international power grids or any complex mechanics. They've started doing it with airline, with jet engines. If an airplane takes off from London to Paris, there's a digital twin that's running for that whole time that the real engine is running. When the plane lands, rather than, these systems are so complex, you can't just look at it and know where the problem is, but you can plug it in and compare it with your simulation, and it'll say, hey, this compartment should be at this temperature, but it's at this temperature, you should look there. So this kind of provides like operational decision support for engineers in, as Marek said, not just in the design, but also in the ongoing maintenance of these systems. So this is an established practice in complex systems engineering in a lot of different areas. And it's really exciting to see it come to the crypto space and tokenomics to make sure we're designing robust, sustainable systems for the long term.
Well, for me, I think this is super important when we're talking about collective systems, or these sort of, we'll call them shared platforms or cooperative platforms, because the technical expertise is really important for decision making and sort of management. And what ends up happening is that if you have a sort of collective experience, whether you're having proposals and voting with tokens or voting based on other rights regimes, ultimately, you rely on how well informed the decision makers are, and in circumstances with high technical complexity, just going with your gut isn't going to cut it. And by building sort of shared analytics, you're actually creating the knowledge required for participation. People can make their own sort of assumptions and then test them with models, look at what happens relative to what they would expect to happen, form opinions and participate in governance, and sort of cut down on some of the risks that sort of those decisions will be dominated by naive opinions. Obviously, you can't totally control that, but it's well known that in a democratic setting, education is one of the most foundational sort of principles. And in a technical system, that's partially achieved through building analytics and models and making sure that they're open source and available and usable by those participants, if they choose to.
Do you guys have insight, like what percentage of the large crypto systems that we have, like blockchains and such today, are sort of a result of sort of just winging it versus like doing this kind of rigorous analysis of the token economics involved?
More winging it than not. I would
Yeah.
say that we've been lucky enough to participate in a variety of projects. A lot of it sort of kind of grindy behind the scenes work, but the principles required are actually pretty robust. A lot of the uncertainty reduction comes from the enforcement of formal invariants, which provide what I refer to as configuration spaces, which comes from the robotics literature. Sort of the algorithms themselves provide rules about how the systems can evolve without enforcing precisely how they will evolve, and that managing that separation is pretty key to robust solutions. And we do see some of that. So anything that's designed based on invariance functions, things like automated market makers and bonding curves, have the sort of the simplest version of this in place. They get analytic guarantees, and the implementations are developed to preserve those, and even the testing that you see from auditors starts to include checking to make sure that these invariants are preserved even after accounting for like fixed point arithmetic.
Awesome. Yeah, and as Dr. Zargham mentioned, a lot of these kind of token engineering use cases, this is kind of when we start from first principles and define invariants, it's almost like you're defining the physics of a system. And we build our engineering off of physics, real world physics. We build bridges, we nature's invariants, F equals ma, gravity is essentially constant at sea level. So this is like, these are invariants that we build with. So defining these invariants in the token dynamics creates kind of a token physics on which we can build this layer of token engineering. And this tool, these digital twins, are kind of our simulation tools to run these ecosystems through all sorts of batteries of tests, both in design and in deployment, that we can now make much better operational decisions off of.
And I think the key is it's decision making when you have invariants, to Jeff's analogy about the airplane engine, because certain things are true. If you observe something you didn't expect, you can infer something about what's wrong, because that thing 1 and thing 2 are going to hold true, period, and you can double check that it did. But knowing that those things held true reduced the degrees of freedom and helps you use techniques like machine learning techniques to identify the specific areas that are causing the issues and to potentially intervene and change that dynamic. But if it were too many degrees of freedom and things are just going all over the place, you really don't have clarity about where to intervene, and all too often an intervention will generate the opposite of the intended effect. And actually that is something that is well studied in sociology and in the social sciences in general, this idea that sort of purposeful intervention often yields counterintuitive results, largely comes from complexity, and the way we manage that complexity is with these kinds of invariants that reduce the degrees of freedom and increase the level of inference when we are working with data and observing behavior.
One thing that the viewers might find useful is sort of like, okay, now we have the physics, we have the formulas, we have the principles, but what does it mean for the users? Like, what's the emergent behavior if you compare to physics? Like, okay, F equals ma, but when the apple, it leads to an apple falling from a tree, right, on Newton's head or whatever. So it's not easy to see, like, from these atomic principles, how does it actually work for the users. So maybe we can try to sort of picture that for a moment, and
a really important thing is that we talk about things, our physics analogies usually end at the level of something energy like. So we won't tell you that humans won't climb Mount Everest just because it costs a lot of energy. We can tell you that it costs a lot of energy. And so, like, what ends up happening with these sort of cryptoeconomic models is that we can say meaningful things about the sort of aggregate trends in these systems according to these sort of physics-like principles, but they won't tell you what any one person will do. They won't even necessarily tell you that certain things won't happen. It will simply say that if this were to happen, it would A, cost a lot of money or effort or energy. And actually, if someone does do that, it tells us something meaningful, which is that it was worth it to them somehow. And so we think of behavior as being expressive, even while we think of the physics as being kind of set. And it's actually the ability to separate the notion of physics as the rules of the game, so to speak, and to sort of engineer the rules of the game so that some things are harder than others, some things are easier based on what we would want. And that when someone takes the path of doing the hard thing or the expensive thing, you should treat that as information being added to the system rather than someone simply acting irrationally. And that's where the digital twins kind of come back in, because you start to have this notion of sense making about, well, maybe something we assumed wasn't right if people are doing things that we thought were unlikely or unreasonable. But again, there's this really careful separation between what I think of as the controlled parameters, or setting the rules of the game, from the observed behavior of the players of the game. And if we don't separate those, we run into a lot of risks of treating, human systems as far more deterministic than they are.
Yes. Maybe just to shed some light from a single user's perspective, a stream owner could go and, specify what they want in some way. They make a, sort of bid or request into the system. And then those people who are running the broker nodes, they attempt to match those requests and join that stream in order to mine it, like inside those parameters that were defined by the stream owner, or the payer role, as we call it in the model.
Yeah, there are other layers in the Streamr system where we have to consider the gap between behavior and rules. So, for example, when the network gives you this sort of instruction, so to speak, to republish things that you subscribe to, that is in the protocol at the level of functionally norms, because there's not a machinery that sort of kicks you out for not doing it. But at the same time, the healthy operation of the system sort of relies on people always, at least mostly, doing the things that they were asked to do. And so we have to deal with this idea that there's an idealized topology of Streamr's peer-to-peer network based on the instructions that are coming out of the software. And then there's a realized topology, which is represented by the actual choices of the individual brokers. And so finding a way to manage that gap, sort of observing that gap, and making sure that we both financially and normatively are prepared to induce behavior that's sufficient to keep the network healthy is, part of this crypto economics research.
Awesome. So we've spent a decent amount of time chatting about the digital twin of the Streamr ecosystem and how that will inform decisions about the protocol moving forward. So I'm curious for the Streamr fans out there, Henri, when will we expect to see the first staking implementations?
Yeah, I mean, in the roadmap, the network incentives are planned to be included in the sort of final milestone called Tatum, which is due in 2022. But so at least by then, but we're making pretty good progress here. And I think already next year in 2021, we're gonna start exploring, like, is there like a sort of light version or partial version that we could implement as a sort of stepping stone to the final model. But it needs to be specified in a bit more clarity. But I think that's the goal, to sort of do it in a sort of iterative fashion. But let's see, there's so many constraints, and also the world is evolving all the time. One particular constraint that comes from the ecosystems that we operate is scalability, of course, and especially gas price and things like this that have been like super sky high this year. And that kind of things, the cost of doing transactions does also have an impact on what kind of models and also what kind of stepping stones you can implement. So the world is now gravitating towards doing side chains, doing layer 2 stuff, and things like this. So it will probably also be the direction where we're going to head. But then the implementation choices and also timelines are sort of influenced by the workarounds that are available for not having actual blockchain like on-chain scalability. but then again, there's Ethereum 2.0 happening and all these things. So yeah, it's all changing very, very fast.
Right, and I think it's important to realize this is, as you mentioned, an iterative process, and also, there are very few precedents for this kind of design. We have, centralized data streaming networks, but bringing this into a decentralized paradigm and introducing a token, and the tokenomics is, of course, a very complex process and needs to be carried out piece by piece and rigorously tested as we go through these digital twins. So definitely, yeah, understandable that it's an iterative process. So for the community that is tuning in, how can they get more involved in the Streamr protocol and tokenomics, and where can they follow up to make sure they're in the loop on the latest information on the evolution of the Streamr protocol?
Yeah, I mean, especially regarding the token economics, I think there will be more discussion about it happening a little bit further down the road. Right now, what they can do is, the best thing you can do is actually come up with all kinds of use cases, like apply real-time data transport to your field. Like if you work in, car industry or medical or some IoT stuff, just think about how you can apply this kind of thinking and tapping into the data economies in your particular field. Of course, we welcome all kinds of code contributions, all kind of discussion about things. But right now, I think the goal is to try to bootstrap adoption of the technology itself, which gets easier and easier all the time. And from 21, you can also start participating in running the network itself. So you can run nodes, even though they won't have the incentive layer yet. But like you guys said, many people have also the intrinsic utility for running nodes. Maybe they have a use case that they want to ensure that keeps running in all conditions. So in addition to running, relying on nodes run by others, they might want to run some nodes themselves, and so on and so on. So this intrinsic utility will already give rise to the decentralization of the network, and then in the Tatum milestone, we'll be able to add in the token incentives, making it even more feasible for people to run those nodes, because they'll be able to cover their OPEX and earn and more, of course.
As a crypto blockchain nerd, it might be fun to run a price feed, real-time price feed.
Oh yeah, there's plenty of use cases, like also in the financial and crypto financial space, and those are the traditional use cases actually for real-time data. Where was the earliest use cases for real-time data? Well, in the 80s in stock markets, right? So financial data is like the cornerstone of real-time, but now with connected devices and all kind of applications and these, more reactive systems being built, it creates a lot of new use cases for real-time data, all the way from data crowdsourcing and this kind of things.
It's really important to remember that the internet itself is a physical thing, and it's often underrated because we're used to experiencing it totally virtually. And as we ramp up the connected devices in the world, the actual topology of the actual internet needs to change, and we can't really expect to meet that demand through centralized CDNs. In the end, we do actually need something closer to a mesh network in order to manage the different, again, like flows, the fact that information will be coming from and potentially going to places where it previously didn't. As it exists now, we sort of live in this very sort of vertical internet where we connect to through our ISPs, and we interact with largely centralized sources and sinks of information, and the sort of IoT connected devices sort of trajectory takes us towards much higher volumes of data just sort of flowing laterally and mixing around, and that is a different topology for the flow of information, and it implies a different topology for the physical layer of the internet.
Yeah, it's true, and it's actually like this if you think about real-time data and data sharing and broadcasting, it doesn't really exist in a usable way on the TCP/IP stack. Like the internet is sort of point to point, so you need to have the parties connecting directly to each other or this centralized server. And this is not good for scalability or security. Like you can't have IoT devices that want to exchange data, like actually connecting over IP to each other. So you need something in between. And usually that's been the centralized thing. But as we go more towards decentralization and peer-to-peer, then these patterns will totally change. And suddenly you don't connect directly anymore. You have these complicated systems of nodes in a network that provide a service that's like a cloud service or a centralized server, but it actually isn't. It sort of feels like it. It works like it does the same thing, but it's actually a replacement for these kind of things.
And it's orders of magnitude more adaptive. So when you think about that centralized architecture, it can only be changed when the sort of, we'll call it like corporate or institutional administrators of that infrastructure make changes. Whereas a peer-to-peer based system will actually reconfigure itself much more rapidly over time in response to either the changes in the economic incentives or even just the changes in the topology itself, the arrival of new participants, or the reallocation of the resources of the existing participants will actually reconfigure the shape of that network in a way that you just don't see in that sort of point-to-point with centralized hub model that Henri was describing.
Awesome. Well, we are getting towards the top of the hour here. So Henri, I was wondering, is there a channel for the community, a best channel for the community to stay in the loop with updates in the Streamr protocol?
Yeah, a lot of people like to join our Telegram channel. So you can find that on our website. There's also Reddit subreddit where you can go and discuss a bunch of things where people can find us. We hang out there. Come talk to us.
Perfect.
Lovely.
Great. And we thank everyone for joining us today to learn more about the Streamr protocol, and stay tuned for another interview that we may have in the next couple of months discussing further model results as the CAD model progresses.